Last week I was at a conference in Leuven in Belgium called SEC App Dev. My coworker Claudio and I were invited to speak at this conference and also host a workshop. It was a full week full of interesting talks and workshops, and I'm very happy I got to go there. The combination of world-renowned speakers and a relatively intimate audience size made for a very unique experience. I think my favorite lecture probably was the one by Lukas Weichselbaum. One of the things that I remember from his talk are the sec fetch metadata headers and how useful they appeared to me. At this conference I got to meet Lukas, and Lukas is a tech lead and manager at Google's information security engineering team. Among his list of accomplishments, you can find that he is a co-author of the Content Security Policy 3 specification. During his presentation at SEC App Dev, Lukas talked about modern security features for web applications. And these sec fetch metadata headers came up. I really like them conceptually. And so when I got back home, I spent a bit of time playing around with these headers to understand how they help protect against cross-origin attacks, such as Cross Site Request Forgery, and how they differ from other protection mechanisms such as SameSite cookies. In this video, I will explain Cross Site Request Forgery, how SameSite cookies can protect against these type of attacks. And if you already know this and don't want a refresher, you can skip to the next part where I explain some of the shortcomings of SameSite cookies and how sec fetch metadata headers can offer a solution. I've built a small web app to demonstrate today's attack and protection mechanisms. Let's take a look. We get the bank of CSRF, and since it's the first time we open it, we get a nice greeting. Hi, welcome to your first time at our bank, and our account balance is $1,000 by default. And if we click the add button, you can see that we're no longer on our first time and that our account balance is increasing, and with subtract it is decreasing. The app is built in Rust using the Rocket framework. I'll walk you through the code. So this is a simplification of an app, but I just wanted some cookie functionality to demonstrate. So we have a get route just for the index page, and in this index we use the cookie functionality. We set a cookie name and then two more variables, the balance and a greeting, so what we want to show on our page. We check if the cookie is present, and if it's not, we set a default balance to $1,000, save it in a cookie, and also set a new greeting. Hi, welcome to your first time at our bank. If the cookie is present, we get its value, and that is the balance that we will display. So this is the page we render. The second route is the add route, and it has a parameter amount, and this parameter is an integer. So not an unsigned integer, it can be a positive or a negative number. In the functionality of this route, we get the cookie and try to parse it as an integer, and then we add the request parameter amount to this balance. This is what we will store in the cookie, and then we redirect to the main page. So let's take a look at what happens when we click these buttons in our network tab. So if we click add 100, we can see a request to our local host address, the add route with amount 100. And if we add to subtract, we can see the same with amount minus 100. Now that I've demonstrated the functionality of the app and we've done a quick code walkthrough, let's try to attack this app with a cross-origin attack. We'll look particularly at Cross Site Request Forgery. So I made a fake website, an evil.com website, which is a phishing website, I guess, with links to our actual website. As you can see, if we go to click homepage, this is, we end up in our regular bank app. But if we want to earn $1 million, all we have to do is click this link. So if you remember our account balance, let's go up to 2,000 is pretty high, but 1 million is of course much more. Of course, this is not what it will actually do. It will in fact subtract $1,000, but a user might not look at this, and if we click this link, you can see that it successfully subtracted $1,000. Let's do it one more time. The balance was 1,000, and if we click this, it successfully subtracted $1,000 without the user intending to. Many cross-origin attacks like this are possible because applications on the internet are connected and they can send requests to each other. Currently, our application cannot easily protect itself from communication originating from other websites. But one way to protect our application from this is by using SameSite cookies. These are actually turned on by default in many cases, but I had them turned off explicitly for this demonstration. So instead of using SameSite none, we'll go for SameSite strict. With SameSite cookies, we can still add and subtract the balance as we expect. Let's add up to 2,000 for demonstration, and voila, this is working like the way we intend. However, if we go to evil.site.com, we can see that if we click the earn 1 million, that this is no longer working. We get an internal server error. However, you'll also notice that currently our balance is $2,000 and this is properly stored in a cookie. But if we click to go to homepage, this is also reset, meaning that even if we go to the index page, we no longer send the cookies. And of course, in this case, it was desired to still have the cookies present and not break this functionality. In order to understand how SameSite cookies function, we need to know what a site is in the context of a browser. In the context of a browser, or in the context of SameSite cookie restrictions, a site is defined as the scheme, the top-level domain name, which is usually .com, .net, sometimes it's two things like .co.uk, and the top-level domain name plus one, which is the domain name that you buy, essentially. And this triple is called the site. And as you can see, the subdomains are actually missing from the site. And so what is the difference between a site and an origin? Well, an origin is the entire scheme, the entire domain name, including subdomains, and the port. So with this context, you might be able to see the limitations of SameSite cookies. Because subdomains are technically different origins, but they are the same site. So cookies on the same site will be sent. And you might have a subdomain such as a forum or an email client or a sort of app where a malicious user could craft links that other users are clicking. In that case, it's possible that cross-origin request forgeries still are possible, and SameSite cookies cannot protect you from that. So let's take a look if we host our own application on csrf.site.com and we still have this evil.site.com like before. And its functionality is still working as intended, as you can see. Let's add our account balance up to 2,000. And if we now go to our evil.website.com, I have some links to the subdomain for demonstration here as well. Then if we click on go to homepage, you can see that we still have the correct balance in our account. And this is because SameSite cookies are working on the same site. These are subdomains, so they are the same site, even though they are different origins. And that means if we click the earn 1 million button that you can already expect, yes, this successfully removes the $1,000. And so across subdomains on the same site, this attack is actually still working with SameSite cookies. So as I've already alluded to before, the solution is to use Fetch Metadata headers. The Fetch Metadata headers are 3 new HTTP request headers that are added to requests by browsers. They are the Fetch Site, Fetch Mode, and Fetch Dest headers. The first one tells us which website generated the request. It can be same origin, same site, cross site, and none. And as you can see, this one is going to be the interesting one for our use case here. We also have Fetch Mode, which tells us the request mode, denoting the type of the request, which can be course, no course, navigate, same origin, or WebSocket. And this can be interesting to look at navigation events, for example, that you still want to allow in some cases. And then you have the sec fetch test, which tells us the request's destination and denoting where the fetch data will be used. This can be a script, audio, image, document, object, and so on. These are relatively new request headers, but they are already supported in all major browsers. Safari was the last one to adopt it with their update to Safari 16.4 in March 2023. And we can see them in action on our own application. So we are now on evil.website.com, and if we go to our csrf.website.com, this should be on the same site but on a different origin. So we expect this to be cross origin. And if we take a look here at the headers and then scroll down to the SecFetch site, we can see that it is same site. But now that we are on csrf.website.com, if we click this and take a look at the new request, we can see that it is now same origin. So this way we can see the difference between a same site and a same origin request. And we can implement some checks in our app to verify these SecFetch headers. In the Rocket framework, this is as simple as adding new parameters to your request. So I've added to the request for our add route a SecFetch metadata variable, as you can see here, of the SecFetch metadata type, which is a type I've created myself, and it's actually just an empty struct. But then we can implement a from request for this type, and in this from request function, I'll get the SecFetch site header and I'll verify its value. So if it's same origin, or if it's none, so whenever the requests are same origin or they are browser initiated, as in typed in the URL bar, then I return a success, and if not, I'll return a failure, a bad request. This is just a simple example, but you can do some more fancy checks. But the main thing I want to emphasize is this is only added to the add route, and the simple index route is unchanged. Here we have the app on our csrf.website.com, and it's functioning as expected. And if we now go to our evil.website.com, you can see that if we click on go to homepage, our cookie is being stored properly. But then if we click on the earn 1 million scam button, we get a bad request. So as you can see, it is pretty straightforward to implement a protection mechanism with these SecFetch metadata headers. You could go a bit more granular and, for example, allow only navigation events to certain routes and allow cross-site requests to other routes, and you have pretty fine control over which routes you deploy which protections, which is better than with same-site cookies. At the same time, you can also protect yourself from cross-origin same-site attacks, such as attacks from subdomains. So I hope you learned something from this video. If you do, give it a thumbs up, and you might want to check out some of my other videos. Bye!